Sorry, I was gone there for a moment. This is the first of a threefold series on mini modules. This first one on enhancing NDCs with MRV, Green Cooling Solutions for Mitigation Action. We will have the second webinar on the 24th of April, introducing the HFC emission baseline tool for enhanced NDC reporting. This one might be too early for the Latin America and Caribbean region, but as we will record all those sessions, they will be also available later on our website. And the third webinar will be introducing the Tier 1 module based on the IPCC guidelines. So within the Paris Climate Agreement, this year, again, will be the year for the updates of the NDCs, of the nationally determined contributions, in order to limit global warming to 1.5 or 2 degrees Celsius. GIZ Pro Klima and especially CFOR2 aims to support partner countries and the regions in introducing the cooling sector into these NDCs, because we know from international studies that the refrigeration and air conditioning sector is responsible for about 10% of all global greenhouse gas emissions. So very relevant also for the Paris Agreement in order to reduce both emissions from energy consumption and from refrigerants. GIZ Pro Klima is promoting this green cooling approach, which means a combination of energy efficient appliances based on natural refrigerants, such as propane, CO2, and ammonia, together with energy efficiency measures. But when looking into data collection, establishing inventories, there's a lack of information in many regions and many countries, which is why this webinar today will illustrate the importance of incorporating a robust monitoring, reporting, and verification MRV processes into NDCs to ensure the effectiveness of green cooling solutions. We will explore how these processes can drive informed decision-making and accelerate the transition to sustainable cooling. And with this, I move to the speaker of today, which is Martin Braun-Santirso from Heat GmbH, the consultancy firm. He will give a presentation on MRV and its relevance for mitigation action. Followed by his presentation, there will be a Q&A session where you can discuss any comments and questions, maybe for your respective countries or regions. You feel also free to ask those questions in Spanish. Martin speaks Spanish, so this would be no problem. Martin Braun-Santirso will explain why MRV matters for ambitious NDCs. He is a senior consultant with Heat, has over 20 years of experience working in climate change, energy efficiency implementation, and emissions reduction. As part of this, he has worked on MRV extensively and has led several projects in climate-friendly cooling. And with this, I would give the floor to you, Martin. I will stop sharing the agenda. So feel free to take over and share your presentation. Thank you very much for joining, and yeah, the floor is yours.
Thank you for that. Thank you for that introduction, and thank you all for your attendance here. As Titian indicated, I'm a well-experienced practitioner of MRV, climate change, energy efficiency, climate-friendly cooling, etc. And today it's my pleasure to be here to give you a short presentation on some of the MRV actions that we can take in the cooling sector. The presentation should be around 20 minutes, but I'm quite happy to have some discussion after. Well, let's take it from there. So my presentation has three key parts. Firstly, I'm just going to have a short introduction of MRV at large and its relevance to the cooling sector. Then I'm going to introduce the mini module that was generated by GIZ with theoretical exercise on the cooling sector, focusing on PV, on the using of solar PV to run cooling systems. Then I'm going to provide a bit of a more concrete example that is close to the theoretical example on the mini module. That was a pilot program that took place in Grenada recently. And then we can have some questions and discussion as needed. So I'll just dive right into it. And if there are any questions, please, as Titian said, just write them in the chat and we'll get to them. Right, so MRV, it's an essential component for effective interventions. MRV, it's standing for measuring, reporting, and verification, refers to the activities that enable us to confirm that what we think is happening, or that we planned for an intervention to have as an effect is actually taking place. This is an essential component then for the actors, the different actors at national and international level, to generate trust between them that enables then countries to have trust in the reporting, or for international organizations to have trust in the savings that are being generated by grants or emissions savings initiatives. And what's more, it is an essential component on being a good manager of interventions or policies in a country, as the information that we get back from projects and programs enable us to tweak them and manage them over time, and fix issues that are happening, change directions if needed, or even when it's needed, suspend programs if they're not having the impact that we're desiring. But when we're looking at an international component, like in the case, for example, of GIZ, that is often supporting climate change projects in countries, it is essential for them to have robust data so that they can demonstrate the impact that they're having with their projects. So this is one of the examples. So that's why I put that little figure there about one of the very many projections that you see out there for emissions reductions. This is the particular figure is completely irrelevant. It doesn't matter for this for the chat that we're having today, other than if we want to trust it, if we want to think that this projection is trustable, then we would like it to have strong, trustable data in it. And for that, we need strong MRV processes. And so why the RAC sector? Why strong MRV in the RAC sector? Well, I'm sure that most of you know, but for those of you that don't, the RAC sector is responsible for around 10% of global emissions, or it was in 2017, 2018, from when this figure was obtained. And this is something that is projected to continue to increase. It's not just about climate change, but it's about countries developing. As you will know, as income increases, cooling is less of a necessity, and it becomes less of a luxury and more of a necessity. And this happens hand in hand with climate change, which is causing warmer climate everywhere. I don't know you, but for example, just last summer here in Japan, where I'm based, for the first time in a row, we had 35 days of 35 plus degrees on a row, non-stop, last summer. So that's unprecedented since records began, and this is just bound to continue. It'll be just a few years from now, and we will see further records being broken everywhere. And with that comes the change, the increased demand for cooling, not just for climate, for climatization and space conditioning, but for refrigeration and in all of the subsectors. So interventions in the cooling sector are becoming more and more important. They're becoming more widespread, and MRV needs to be part of this intervention so that we make sure that the impact that we intend is being had. So, and as indicated before, the impacts of MRV go beyond national and international reporting. The benefits of MRV are widespread. Robust data results in improved policy making. It results in increased accountability, not just by the international organizations, but by national organizations, regional organizations, even local councils, local implementers, which also leads to improved results, which in turn will drive demand for robust data in its own right. So from our perspective, in the climate sector, we believe that an MRV component should be part from the very, very start of any project. From the planning stage, there should be plans and budgets allocated for MRV activities. The scope of MRV activities will change depending on the project, will change depending on the level of implementation. From an organization like GIZ, for example, they will probably want large-scale data collections at country level, at continental level, for understanding how actions take place and how emissions are being reduced. But this can go right down to local level, to even implementer level. And in the case of the example of this project that we're going to be looking at in the mini module, it's just one single sector that we're targeting. So it can be very targeted MRV activities. The scale of the MRV activity should be targeted to the scale of the project itself. And the consideration should be that the data produced should be able to be fed into higher levels of reporting, so that then it can be fed into systems that track the entire refrigeration and air conditioning inventories, and then into national level policy. In the case of the mini module that we have here, the idea was to provide a theoretical exercise for training and capacity building that enables the readers to consider what would the requirements be in terms of MRV for a localized project that supports the deployment of solar PV to support cooling activities, right? So for this, the mini module will support then the conceptualization of the main MRV components in the system. So for example, in here, we identify the 4 key steps to set up. So the first one is identification of the MRV system objectives. And this will, of course, align with the objectives of the project at large. So most of the interventions in climate change will have the ultimate objective of having an estimation of emissions reduced. However, the amount of data and the variables that need to be collected to get that in a robust manner need to be all identified individually, and a data collection process set up for that. And that comes to point number 2, the establishment of monitoring procedures, whether it be electricity meters or just reading electricity bills at the end of the month, reading power generation from solar PV, company reports on expenses relating to electricity cost. There is a variety of options that to be taken, and different ones will suit different objectives. So there is no one prescription for this, other than we need to make sure that the data, the numbers that we're getting, are robust and believable and transparent. That's very key. It needs to be transparent so that it can be repeated in other countries. Identification of the reporting needs. Here comes that is the very next step. Reporting, of course, is an integral component of MRV. There are component, and as I said before, you know, when somebody's supporting activity, or we need to meet policy objectives, even as a business owner, if I have stakeholders, partners, etc., I need a report that says, well, this is what was done, this is what was achieved, and this is how it was achieved. So the reporting needs will vary depending on the level as well, and we need to identify these needs and then address them as part of this planning process, and then to generate the reports as needed. And finally, we need to identify what level of verification requirements are needed, so that the reports and the data that we produce are believable to third parties, right? So this verification can include just self-data checks that verify that the data is of good quality, that it represents what it's meant to represent. And this goes right down to where there is requirements for third-party accredited verifiers, like the international verification companies, like Underwriter Laboratories, that provides certifications for product testing and whatnot, that are extremely detailed and extremely strong reports that are needed at a legal basis in order for products to qualify for entry into countries, etc. So this verification process needs to be identified, and each project will require a different level. So for the mini module, the interventions identified happened at 2 different levels. So the option number 1 was a residential solar PV program, and the idea here is to support residences to purchase a PV system that will feed into their cooling by incentivizing homeowners either through tax breaks or direct subsidies, feeding tariffs, whatever it might be. The target it targets the energy needs of cooling systems. So the PV systems need to be sized accordingly in this interpretation, in this intervention, and not only sized accordingly, but they need to be installed in a manner that we know that the PV system will be used for cooling, or will directly offset cooling demand, and not going to be just used for other purposes. So this will include outreach program to make potential targets aware. They will require to have an education program for homeowners as well as installers, so that the right technical skills are put into place. The option number 2 will be a similar program, but this is addressed for commercial. So again, we're looking at either a market incentive or a financial direct incentive to support this. The nature of the intervention is less important than the final objectives, right? So the rationale of the intervention here is that there's a combination of two impactful strategies and technologies. We have energy efficiency. Well, we have primarily renewable energy for this particular thing, but they usually often go hand in hand with energy efficiency. And programs like this could also be sized to go in tandem, energy efficiency and efficient cooling, to have a double a cumulative impact. Benefits can go beyond just the direct users. This can reduce grid emissions, can lower stress in the electricity grid. And this is particularly applicable to warmer weathers, such as in the Caribbean islands or the Pacific islands or tropical countries, where it's usually hotter during the day when there is sunshine to generate the power needed for cooling through the PV systems. So the intervention objectives here, we're going to go, if we remember from our previous slide, over here we've got the four key bullet points in order to kind of identify and design an MRV system. So firstly, we're looking at the objectives. So the ultimate objective here, of course, will be to reduce the climate impact of cooling activities. So this means reducing emissions, and it also looks at deployment of renewable energy for the same ultimate objective of reducing emissions. However, we can see that there's a number of co-benefits that could be had and could be targeted by an intervention. For example, we could be looking at job generation. We could be looking at delaying new infrastructure investments in the electricity sector. So there are a number of possible co-benefits that could be had here. So when we're looking at the key performance indicators to measure the success of this project, to measure not just the success, but to measure the performance of the project, so we can look at variables such as, well, what's the number of PV systems installed? What is the size of the system? What is the compatibility, or have there been compatibility issues with cooling systems in terms of feeding the electricity directly to cooling systems? What has been the total amount of kilowatt hours replaced through the photovoltaic generation? What is the total amount of emissions reduced? And then we can again start looking at the co-benefits, job creation, grid stability, reduced deferred investment, etc., etc. So, so we have here objectives, and we have identified some key performance indicators. Then we're looking at, well, how do we gather this data? What are the key options for data collection? So some of the key variables as identified, we've got PV output. So this indicates how much is the total amount of kilowatt hours that were generated through PV. We need to measure the total amount of kilowatt hours that been demanded by cooling systems in the same locations. So this could include direct power meters to different appliances, estimation of amount of usage. This will depend a bit on the individual program. We need variables like the grid emissions factor. This means in terms of the grid electricity in your country, how much are the emissions per kilowatt hour. So recently, when we did the project in Granada, as I mentioned before, we have a pretty high emissions factor because they have a high dependence in fossil-generated electricity. But I recently worked in Costa Rica as well, and they have a large amount of hydro and other forms of renewable electricity there, so makes their grid emissions factor quite low. It's important to establish a baseline of performance. That means what is the performance like at the moment, and ideally what it would be like if there is no intervention to take place. And this is why I put this graphic in place for most of the work that I do. When we're estimating emissions, when we're producing MRV processes, MRV projects, when we're doing a RAC inventory or a national cooling plan that looks at the impact of emissions up to 2050, we need to establish a baseline. In this case, again, it is not relevant right now that you understand specifically the setting of this graphic, but just to understand that you can see that there is a baseline of performance out to 2050, and then we estimate what the intervention will look like, and then we keep collecting data to validate the initial estimation or to correct it. And as I mentioned before, that's how we can then actively manage our projects. So some of the options that have been used, we can use smart meters, we can use logs of solar power generation. We can use audits, user surveys. Before I indicated electricity bills. There is a variety of options. For the next step, then we have to do reporting, and one of the essential components of this is that reporting needs to be consistent, right? We cannot keep changing the format, the units, the timing, the time periods for our reporting. And the reason that you have these graphics here, this table that have no actual data in them, is just some examples of the formats that I use in my own reporting. And I stick to the same colors, and I try for entire reports, I use the same color for the same variables where possible. And in terms of the actual numbers that I produce, I will do things like make sure that the reports align with international requirements. For example, I use the same units as the IPCC in terms of time, in terms of emissions. We use consistent templates, and we try to incorporate this into existing national MRV platforms as well. So this is very important. If your country already has reporting platforms, they already have, for example, a robust mechanism for producing greenhouse gas inventories, then the best idea is that the reporting needs for your project should make sure that you can feed this right into this into these mechanisms into the future. Particularly when these projects are vertically associated with implementing agencies like ministries, Ministry of Environment or Ministry of Energy, that then they will report at an international level, then the alignment needs, it's an important component to be sought for this, for ease of use, for relevance to a larger number of users, and for maximizing the value of the data in itself. And finally, as we discussed before, it's all about verification. We could just look at, for example, just initially it's just self-verification. We install a meter and we need to look at the data that was generated by the meter. And we need to look at that. It makes sense. If a meter tells me ridiculous numbers, like I don't know, it's just, a small business, and it tells me that I'm using 10 times the electricity that I pay for every month, and there's something wrong. Then you can do things other like cross-checking. For example, if the meters or the data that I got tells me that I'm using the exact same amount of electricity, whether I have or very similar amount of electricity, whether I have 10 people or 50 people in a particular building, then we need to check that the data that the meter is working appropriately, etc. So this is where I mean by horizontal and vertical data checks and cross checks. Other options include sample testing. This, for example, happens a lot in MEPS programs where specific units of certain appliances, a refrigerator or air conditioner unit is going to be selected by the implementing agency to be tested by a verified third-party certified insurer, etc. So the level of certification again will change. So if you're a business owner reporting back to a government grant, the government grant may require you to have notarized electricity bills as part of your verification, or notarized electricity meter logs, etc. So these are just some of the examples that we need to make sure that data is what it needs to be. And we see this a lot when I put the example here of these tick marks here because we see online often certain agency and certain organization gives a tick mark to a product. That means that to a point it's been verified, it's been tested, that gives you the confidence to buy or gives you the confidence to use a certain product or a service. So it's the same for the data that we have. We need to have the confidence that it's been tested, that it does what it needs to do. And then finally, we need to repeat this process. We need to have this process be continuous, right? So throughout the life of interventions or projects or policies, and for some vital country level indicators, the country itself will establish continuous monitoring. Again, I put a graphic here that it is not really relevant, the content in itself. The idea is, you see many of these kind of performance dashboards in many places that give you data at your fingertips, depending on the size of the project, depending on the type of organization that you have. For example, if you have a very large PV setup system, you may want to have a pretty developed dashboard to make sure that all that investment that you put into it is at full operation and it's not costing you money where it shouldn't. So you have dashboards that tells you the level of production, the daily or hourly or even live level of electricity generation at all times, and it's able to detect when there is a drop-off when you shouldn't have. That indicates a problem straight away that can be fixed. That in that way you're not wasting away solar hours, that kind of thing. And this will allow decision making. So it supports investment decisions. It supports operational decisions. And something that is very important to understand in developing countries is that having a good background of data collection and having strong data supporting projects is often a defining factor in having finance access from international organizations. I once sat in a project, in a conference where a lot of people are saying we need funds for this, we need funds for that, and then funding organizations and saying we have funds for this, we have funds for that, but we need you to prove to us that you can do what you say you can do. We need you to, collect some data and give us information as to how many, when, how, what is the security of this investment, etc., because it's often tied up. And if you ever go to private sector financing, that's becoming even more stringent, as when you're going to ask money from a bank for installing solar power, they want to make sure that you're going to do a good job. So if you have a long history of producing, they're more likely to give you another loan for more solar, etc. In terms of setting up these continuous monitoring programs, there is going to be a number of roles and responsibilities and at different levels. So government usually establishes frameworks for reporting, for data requirements. The implementers need to collect and validate the data and make sure that there's reporting done as required for the government. Independent verifiers, they conduct audits and confirm the impacts, and platform providers will often be the ones that host and manage these digital tools that I have been showing a little bit today. So in a nutshell, this is what you will find in the mini module. I hope I have not given you too much of a download of information to be confusing, but this is the generic component. Now I'll just briefly run you a little bit through the example that happened in Grenada, and then we can have some discussion. I'll go through this a bit quicker so that there's more time for questions. So the Grenada project supported a pilot project to deploy some highly energy efficient and natural refrigerant air conditioners in a hotel in Grenada. And one of the conditions was that the hotel would have already a significant amount of solar power in order for the cooling to be able to be directly supported by the power generation. Now, this is important because in tropical countries, as we mentioned earlier, there is large demand for cooling. About 48% of energy demand in the Caribbean is estimated to come from buildings, and the great majority of this will be in cooling because of the climate that you have. Similarly, in the Pacific, especially in Grenada, there is very high reliance on fossil fuel generated electricity, allowing for very high potential for reductions through efficient cooling and PV for cooling. And in the graphic on the side, this actually is relevant for you to see the actual data, as this is the pattern of estimated growth for cooling demand in Grenada. And as you can see, between 2010 and 2050 is estimated to more than double. So this is a very relevant area for reduction. And you can see also that air conditioners are the main source of growth. So in the MRV for this pilot project, we looked at the consumption of electricity of old units versus new units. And this is what you see in the graphic on the right. We attached meters to each of the units, and we estimated the daily usage throughout different months for the units. So you can see the daily usage here. The orange month is August. This is you can see for most of the months is the largest month. Then the units were installed in September. That's why there's no data for September. And then we have measured data in October and November because this is a short-lived pilot project. This was the duration of the project, and this is why we have a relatively short-term data set. But for longer-lived projects, of course, you want to continue to collect this data through the life of the project. But here you can see very, very quickly how data was collected prior to the installation as a baseline performance that we discussed before, and then we continued after to estimate the impact. So we have the system loads in kilowatt hours, in kilowatts, in total kilowatts. We have the consumption of the new units. We have the electricity cost. We have the solar system production. We established a baseline. And for the long term, the data loggers and Excel databases are the same tools that could be used to establish continuous data collection. Sorry, yep. There we go. The key results that we estimated here is that even with relatively higher ambient temperatures in the later months, there are 290 units, so these are the new highly energy efficient units, outperformed the existing units. And the emission savings come significantly from electricity use, but also from refrigerants. Key highlights of this performance, and you can see the data in the table. I'm not gonna spend too much time on that, but you can see that there is 35% energy savings even during the hotter months. This was only with 2 months worth of data, but it should be easily projectable, or it should be easy to assume similar performance gains over the lifetime. When we extend these savings over the lifetime of each individual air conditioning unit in the Granada electricity grid, we are saving about 10.5 10.5 tons of CO2 for each air conditioner. And this turns, in terms of the electricity savings, they translate to about $5,300 US over the lifetime of the unit. So this is more than the entire cost of the unit of installation and whatnot. So, and the idea of the point of this is to demonstrate that, you know, just spend a little bit more upfront in the investment, and this will pay back over and over and over the life of the units. Insights from the verification process. So we had some insights. So, for example, in the verification process, the cross checks of the data were essential, as we identified some data mistakes in the collection process, such that we were able to weed out the data that was not of quality, to stick with the data that was of good quality. We used relatively conservative assumptions not to oversell the gains. We used calibrated meters for the collection of the data. The error of the incorrect data was not to do with the meters; it was to do with how we stored the data. And there is transparent documentation as to how the data was collected, how was it analyzed, etc., etc. With that, I think that's it. So key takeaways: MRV should be integrated from the planning stage. The system of MRV should be fit for purpose, not too complex, not too simple. So this is key. So for each project, MRV enables evidence-based scaling and finance access, and adaptability is key in survival of many projects and policies, and using MRV to refine interventions and to manage them on the go will maximize the success and maximize the bang for buck that you will ever get when you invest in these interventions. I have some links here, firstly to the module, but also to some other relevant web pages regarding green cooling and natural refrigerant cooling, etc. But with that, I will cede the floor. Sorry, I think it took a bit longer than expected, but I'm happy to answer questions.
Thank you very much, Martin. This was very interesting and great to have this combination of MRV on this theoretical level, and then the best practice example from Granada to see in practice how this could look like, and also to see the actual energy savings for this pilot project. And yes, as Martin mentioned, please also download the mini module from our website. We will post the link to the mini module into the chat, and there you will find a lot of information also on those steps to achieve the MRV system. And with this, I would go over to the Q&A session. I saw some questions in the chat. For Martin, if you have any questions regarding the presentation or regarding how to set up an MRV system for the integration of the cooling sector into the NDCs, feel free to post them into the chat. As I mentioned, you can also post your questions in Spanish. Raise your hands.
I see already one question. Sorry to interrupt you, Tizian. I saw a question regarding direct emissions.
Yes, this was when you were on slide 10, I think. You had the
slide 10.
Slide 10 regarding the baseline and then the
this
potential for reduction. I think there Rafael had this question regarding if direct emissions were taken into.
So usually when we do any analysis of the cooling sector, we do look at direct emissions, definitely. And that's why we are very keen on natural refrigerants. In Europe, they already have the F-gas regulation that is going to reduce the access of HFCs as refrigerants into the market. And for everything we do, if you see in the last table of results that I provided, I think that we have that one there. We have refrigerant associated emissions that are also included in the analysis.
Great, thank you, Rafael. I hope this answered your question. If not, feel free to activate your microphone and ask more in detail. Perfect. There was another question. Yeah, go ahead.
No, I noted later in the table that is taking consideration the emission.
Okay, great, thanks. There was another question from Dr. Coffey. If there's a software tool for the continuous monitoring, a software tool that is available, if you have any recommendations.
So there are a variety of software tools. Yeah, I mean, the software tool for monitoring will depend partly in your monitoring hardware and what software talks to your hardware, right? So different softwares talk to different hardwares. So it's a bit difficult for me to provide this now. What I can tell you is that the majority of meters, for example, those direct automated systems, do produce data sets in Excel that facilitate access and make it that way not expensive for you to use not just Excel, but the freely available Google tools. I know that this could be important in developing countries, as often the amount of money available for buying dedicated tools is not available. Yeah, unfortunately, I don't have a lot of recommendations in this regard because it depends a lot on the hardware that you're able to get for the automation. But yeah, normally the analysis can be done outside of these paid systems that require payment and do it outside.
Okay, thank you for this answer. Ali Kadum, yes, please go ahead.
Yes, thank you, sir, for your presentation, and we appreciate for all the effort to view for us the scientific administration monitoring for the whole system. I agree with you. It's necessary for us to move on this process. But my question, if we are a country depending on the fossil fuel, and our system is dependent on all of its, we need an incentive to move on MRV system for the investors that can share us the carbon credit for that means. So I know this is NDC, but there is private sector we can encourage it to enjoy this technique and apply their administrative cost to apply this system. So we need encouragement for our case to implement this process in the mean of carbon credit in order to have well, most important part in emission reduction. Thank you, sir.
Yeah, I mean, MRV is a process that I think, as I said before, has different areas of application. So, for example, something that can be done for private sector is for government to make some mandatory requirements for annual reporting for certain private businesses that could help with some of the data that you can collect. And of course, you know, in terms of them actually carrying out activities to reduce emissions, yeah, for that, it'll be important to get some investment and some incentives. But as I mentioned earlier, if you can start looking at the areas where you think investment is required, then start looking at what information and what data is available and see what kind of data could be collected at a very low cost, so that when you ask for these incentives, you have a lot of good backup of data backup, so the investors can see that if they invest money, the likelihood of a return would be good, because the project will have strong impacts.
Thank you for your response. I'm not sure if there are any further questions. Otherwise, maybe we can come to a close.
If you receive any more questions after this, I'll be happy to respond to them by email.
Okay, that's perfect. Thank you for the offer. I also wanted to mention before we go, feel free to reach out to us also and to have a look on our NDC help desk. We have a help desk which sums up most frequently asked questions regarding NDCs in the RUC sector, also a variety of publications, and there's also a contact form where you can ask your specific questions, maybe also regarding MRV systems. So feel free to reach out to us via the contact form on our website. We will also upload today's session on the website, so you can also share this webinar with your colleagues or come back to it at a later point. And then, in the name of ProClima, I would like to thank Martin for this very informative presentation and for answering the questions, and also thank you very much to all the participants for coming to this webinar. I hope this was informative and will help you for your MRV system, and hope to keep in touch. We will inform you about the next webinar, and we'll share all the information with you. And with this, thank you. Have a good day. Take care, and until the next webinar. Thank you.
It was my pleasure.